Where's the noise? I'm there. I'm there. Okay, yes. So I said we stopped our last class under examples of simple harmonic motion. Please, that's the noise. That's the noise. So see what I'm going to do. This side is for my simple harmonic motion. This side are for the terms related to simple harmonic motion and the examples of simple harmonic motion. This one is for my simple pendulum. Please pay attention so that we can quickly solve those questions and go home. Simple pendulum. This one is for my loaded spring. So we'll be fast, it won't take long. So please, the first one is what I call period, or what we call period. And we know that period deals with time, it's not period. Yes. So for a simple harmonic motion, the period is simply gotten from that equation, which is 2 pi over W. So that is what you have for simple harmonic motion. While for a simple pendulum, we have that the period is 2 pi root L over G. Then we have that for a loaded spring, that the period is 2 pi root M over K. Yes, thank you very much. And we know that period is simply the time to complete one oscillation. Is it not true? Yes. Now, the next term I want you to note is what we call number 2, angular frequency, omega. So this is the angular. Please let's be fast so that we can solve our questions and go. If you don't call it angular frequency, you can call it angular velocity, omega, W. So this angular frequency is gotten from that part where we normally do that W is equals to theta over T. I don't know if you still remember this.
Yes.
Yes. So from that our W equals to theta over T. We can now have that I guess this where theta is equal to WT. I know that theta is talking about degree. Alright. Now for simple pendulum, we can simply give this by simply saying that frequency is 1 over T or 2 pi F. Yes, or 2 pi, oh yes, or 2 pi F, yes. Angular frequency. So we can say that W is equal to 1 over T or 2 pi F. Somebody will be wondering what are they doing. Remember that this thing is the same thing as saying 2 pi over T. Should you still remember? Yes. That theta is the same thing as 2 pi over T. Yes, so if you check it, let's say I put these two things together now, 2 pi over T. If you push it, you can see that that's where I got that T is equal to 2 pi over W, which is up here. Should we? And if I remember that T is the same frequency. Okay, when we get to frequency, we'll talk about frequency. Alright, so that is how we have it. So the same thing with loaded spring. You can say that the period of the loaded spring, the angular frequency of the loaded spring is simply 1 over T or 2 pi F. Alright, so the third thing is what we now call frequency itself, number 3. Frequency. In our last class, we derived velocity, we derived equations. So go and check that video, the first video I posted. So this is where we start. So for frequency, we know that frequency is simply given. So if I check it here, looking at this very well, I'll see that if T is equals to 2 pi over W, and naturally the frequency is always 1 over T, shall we? Yes. So I can go back here and reverse what period is. So I can simply see that this is going to now be W over 2 pi. Are you seeing it? Yes. Another way to do it is to say, notice that W is equals to 2 pi 1 over T. Are you seeing it? Shall we? So if I push it well, I see that yes, T gave me equals to 2 pi over W. So the T is giving me over W. Okay, still the same thing. However, I want to run around it. It's still the same thing because I'm still going to do that inverse, the reciprocal. Yes. So I'm going to be having that this is simply W over 2 pi. Yes. And if you put it, it's still the same as saying when I have W equals to 2 pi F. From that place, it's the same thing as saying if I want to make F solid for the formula here, I'll divide both sides by F. Is it not true?
Yes.
So let me divide both sides by F, divide both sides by F, this will cancel. So I'm having W over F equals to 2 pi. So making F solid for the formula, what do I do? This will come down here. Shall is it not true? Let's check. I'm having W over F equals to 2 pi. Shall we?
Yes.
Okay. Okay, so if I want to make F solid for the formula here, what do I do?
W is equal to 2 pi. W on 2 pi.
W on 2 pi?
Yes.
Okay, which is the sentence? I could have as well just done multiply both sides. Or divide both sides by W.
Yes.
Shabi?
No, by 2 pi. Divide both sides by 2 pi initially. Yes.
We're running around on the left hand side. So it's the same as saying instead of suffering myself, I could have just done since F is here. Let me just divide both sides by 2 pi. That's why I like maths. We just do nonsense, it will trick you. Alright. So F is equal to W over 2 pi. So there is no need deriving this if you remember that period is simply 1 over F and F is simply 1 over C. So if I take the same thing.
The frequency is in revolution.
If the frequency is in revolution,
it doesn't fall in any of this whether simple or simple terminal or low spring. Does it fall in any?
Notice that where we are still in simple harmonic motion. That is why we are grouping it. I'm giving you what F is for simple harmonic motion. Then when we move to simple pendulum, we know that simple pendulum are examples of simple harmonic motion. So if there is a case of revolution, I will now remember that frequency is also the same as saying revolution per second. Then I will now be checking the revolution if it's something I need to convert to degree or to radians. So that one is not really a problem. So we can also say, we can use that thing that you're saying now to define frequency. We can say that frequency is simply the number of oscillation per unit time. So the number of oscillation in a given time is what we call frequency. Alright, so F. So for simple harmonic motion, W over 2 pi. So please, if there's any question given to you, they tell you a simple harmonic motion did whatever, and they tell you find the frequency. Notice that the first thing you need to be checking is if they gave you W or 2 pi. Yes. For a situation whereby, for example, they tell you simple pendulum was the frequency, that's where you can just check if you already know the period. So now say that this is going to be simply 1 over T. Very simple. 1 over T. Or I can still remember that it's the same as saying revolution per seconds. And remember that the unit of frequency is what?
Yes.
Then the unit of period is seconds, right?
Yes.
What about angular frequency?
Radian seconds.
Radians per second, Jimmy?
Yes.
Please, if you've not checked my video on simple harmonic motion, the first class will be the simple harmonic motion. Go and look at it. Very important. So now I'll have that for the next strength is the same to 1 over T revolution and seconds. Okay. Now the next thing, which is the velocity, the fourth one, we've derived these velocities, but we just want to mention because they are key characteristics of anything SHM or simple pendulum or loaded spring. So for velocity, the case will come when they ask you what is the maximum velocity or velocity at the lowest point. If they ask you velocity at the lowest point, it's the same as maximum velocity. So if I know that this velocity is given by AW, is given by AW at the lowest point. AW, I did not say intermediate point. We've already talked about derive these things. Now, if it is simple pendulum, this is given by believe I'm not mistaken. Yes. So this is given by A into L minus L cos theta. We'll still do that one for simple pendulum because remember today we have to solve questions. So A into L minus L cos theta. And this thing is the same thing as saying, A into, AL, or, sorry.
AL minus AL cos theta.
Yes, AL, yes. 1 minus. Then 1 minus cos theta. Is it true?
Yes.
Check for me.
No, it's not the same thing.
Because you know that this AL can go here.
Yes.
And you have AL. It can go here as well. Yes, this. Yes. So if it enters here, it's the same as AL. If it enters here, it's now yes. So I'm correct. Okay. The same thing here. So whichever one wants to use. Then we know that for the acceleration, number 5. Acceleration, we've derived all these things guys from this one and this one. We derived the acceleration. We said that it's the same thing as saying, if you still remember, WX squared. You still remember?
Yes.
Or WY squared. Ahead.
W square.
No. It's always the displacement that is being squared. That is when you check that. If you remember that our principle of WA equals to WR squared. So we can replace this R with its displacement at x axis. We can replace it with its at the y axis. We can replace it with even A if it's the highest displacement. Remember that amplitude talks about maximum displacement. This remember.
This is number 5 is centrifugal acceleration now.
Which one?
Or it's just acceleration?
Hey. Maximum acceleration is given by WX squared. Yes. So I have WX squared here as well. So this is what they have in common. So please, with this said, I just gave you this. We don't derive anything under this ones. Because we want to solve questions. As we're solving questions now, we'll be deriving it. But in our last class, we derived everything here. Now please, the last and the 6th one, amplitude. You can just write amplitude is the maximum displacement. So at maximum displacement, R is equal to A. So amplitude is simply the highest displacement. So if I have, for example, A cos theta, whatever I see first is my amplitude. So it has no equation. You just know that it's the highest displacement. If they tell you that that thing moved to a point of 60 meter and is the highest displacement, they know that they are talking about displacement. Okay. Just because you are just coming, we've already done all these things. Check that first video question. Somebody said something about getting omega as square root of k over n. If we're in our last class, have we not done that? Yeah. It's on YouTube already. Check our YouTube video. Everything about deriving all those, all the equations, like all those our omega, where we pointed out w square, guys. Can I claim? Yeah. No. We are copying fast. I don't want to go back to that class. That's why I posted that video. Go and watch my video on Simple Harmonic Motion. Go and watch my video on Simple Harmonic Motion. Please, any class we fix, even if you are not in class, if you post the video, watch it. I have reason. Physics is one course that you need to know how it started. Because it involves calculation and it involves the story part. Let me clear. So please, you can add to this loaded spring. Anytime you did not see mass, anytime the loaded spring, you are not giving mass for the loaded spring. Another formula to use is 2 pi root x over g. We've derived it. In our last class at Hobby, we derived it. Some persons finished palastology practical that day. They made it a point of duty to come back to Hobby. Some persons finished and went home. People in Hobby, they are playing. Yes. So we derive all these things. All these things I'm saying now, to look like formula you are copying it down, it might not be very interesting to you. But assuming you enter that class or you've watched the video, on the derivation of all these things, it will be making more sense to you. So go and check that video. Today's class, I just want us to use the time where solve questions and go home. You see all these things I gave you now? Once you don't remember it, if you enter exam hall, when they give you a question of simple harmonic motion, your mind will tell you simple pendulum, you can't be using another equation. So it's important to know how to classify these equations. Now when your question is asked, you are checking if it's simple pendulum, if it's spring, or if it's simple harmonic motion itself that you are looking for. Oh yeah, please, I want you to now check the question we have. There's a PDF I posted. Let me read it. For those of you just joining the group, check your friends, what they have. So there is a question there that says, a body is supported by a helical spring and causes an extension of 1.5 cm in the spring. Have you seen that question? No. Check. The PDF I posted to the group. A body is supported. I don't know the number, but if you look, you will see it. If you count after the first one and the second one, we're solving everything, but I want to start with this one because of this last formula I gave you, x over g. The body is supported by a helical spring and causes an extension of 1.5 cm in the spring. Have you seen it? Yes. If the mass is set into vertical oscillation, calculate the period of oscillation. So they said a body is supported by a helical spring and causes an extension E is 1.5 cm. And you know that this extension is the same as x. Do you agree? Yes. Of 1.5 cm. And we know that cm to meter is what? So if you divide by 100, what do you have? 0.0. For those of you that don't know what we did there, we'll simply say 1 meter is equal to 100 cm. So we'll now put 1.5 cm. Against times, we put cm in the place, cm can cancel cm. All over, that is 100 cm against 1 meter. So, shall we? So that by the time you do it now, you see that this will divide this. I punch it, what do you have? 0.015 meter. Alright. So that's the first thing they gave me here. Then the next said, if the mass is set into vertical oscillation, calculate the period. That is T is what I'm looking for. See, I don't know it. But we know that for a spring, according to the question, T is simply equals to 2 pi root m over k. Is it not clear? Yes. So please, you also need to go and write somewhere close to that your work. The frequency of a spring is also 1 over 2 pi root k over m. Yes, the frequency is 1 over t. And when you do 1 over t on this formula, for that loaded spring, you will see that it will give you this thing. So frequency for a loaded spring is also 1 over 2 pi root k over m. Notice that if you are reversing everything here now. Yes. So I thank God I remember it now. Now see, if I put 2 and 2 together, I need to remember from that our first class. Some people just want to copy. From our first class, we said something that f is equals to minus ax. Is it not true? Yes. And I told you that this minus is not useful. That is only there to point that the displacement is in opposite direction to the force. Yes. Don't ever use it to calculate. Because if you come and put that f is equals to kx, it simply means that what you are doing now is that it moves and continues moving. So you are saying that the definition of simple harmonic motion is that it is that periodic type of motion that moves to and fro about a fixed point, whose displacement and acceleration moves in opposite direction to the restoring force. So that's what this thing is doing here. So, but when I want to really solve, what I'm using is simply f equals to minus kx. That's what I'm using. Sorry, kx. Because this is direction. So from here now, it's from here we make k subject of the formula. And when you make k subject of the formula here, it simply means dividing both sides by x. Is it not true? Yes. So k is equals to f over x. So for a spring, we take it that if we don't have f, that f is the same as mass and gravity. Yes. So all over x. So if I now carry this x now, notice something. If I now carry this mg over x, here me now and replace for k, I will get something that will cancel this m. Because notice that I don't have m.
Oh, sir. Okay, it's the same thing.
Your blood is hot.
Yes, there was a formula you just added. That it will arrive to you.
Yes. Try and be attending all the classes. Even if you finish parasology, you hear that there's class. Come for class. That's why I cancel yesterday's class. Because I noticed that assuming we continue with yesterday's class, you still see that the number that will come will not be much. In fact, once we finish class, that people go for practical or the rest, I know people that will come. Yes, I know the number of people that I'm expecting, the kind of people that will come. Those are the people that if you don't fix class in the morning, like in the morning, they'll be asking you, sir, will you still fix class in Obi today? Yes. But those other ones, they don't even think of the fact that you paid for the class. So some people, if you say no tutorial, they will say, thank God. Your money. It's alright. So let me carry mg over x and substitute for k. So that I now have t equals to 2 pi root m over everything here for k, mg over s. So inside here, we can now start doing that mathematics of saying that this thing is the same thing as saying root m divided by mg over x. Is it not true?
Yes.
And we know that mathematically, if we put multiplication here, this will reverse. Shebi?
Yes.
So that means that this can now cancel this. So that we now have root x over g. So instead of suffering yourself to do this thing, anytime you notice that there is no mass given, just use 2 pi root x over g. So now I can now substitute. So I can now say that this thing is the center. I've gotten it that is the center. I say 2 pi root x over g. Now please give me my x is what?
0.05.
0.015. Should it?
Yes.
Then g is constant.
Yeah.
Can use 10 or 9.8. So punch for me. What do we have? 2 pi is 22 over 7, right?
Yes.
I'm coming, you ask. So this is now going to be the center saying 2 times 22 over 7. Do for me 0.015 divided by 10.
0.015.
Like this, should be? Yeah. Here for me now. 22 divided by 7 is 3.149. Times it with 2. Then do square root of 0.0015. What do you have? Like, give me your final answer. That's what I need. 0.242, which is 241. Okay, which is approximately 0.24. And you know that it's period we are looking for, right? Which is in seconds. If you attended the first class or if you've watched the video, if you go to YouTube, check SHM. And I said equation. I put equation, velocity, and energy of simple harmonic motion. There's nothing you want to think of. Energy of simple harmonic motion. There's nothing you want to think of now as to how to derive simple harmonic motion or whatever. And you did not do there.
If you play this step, 9.8,
Okay.
like this will be aspiration of 0.25.
Okay, if you replace it with 9.8, it will give you 0.25. Are you sure? Punch, let's see.
Yes.
And it will give you 0.25, which is 0.3.
Yes.
That means that whoever punched this one, when you do 0 divided by 10, is it not supposed to give you the same thing? Check. 0.10. That if you use 9.8. Me, I like this in 10. So I'm going with 0.24. I don't know if it's your calculator.
0.24.
When you did 9.8, divide by 9.8. Wait, with 9.8, you got 0.5. Okay, you got 0.24, Shebe?
243.
What do for me is 9.8 divided by 9.8. Let's see what you have.
Yes, 0.245.
Okay, it's not giving 0.245.
Yes.
Right?
That was it. So the calculation is 0.5.
Which is approximately 0.3. Shall we see his problem? For me, I like using this, but even the truth is that 9.8 is more correct. So, you know. Okay, no, 9.8 is more correct. Yes, but I like using this. So whoever is marking it, it's now up to you to be checking what answer you have here. But I will advise you as my student, 9.8 is more correct than this because the more decimal places you have, the more correct your answer will be. I've always said that. Alright. So we know that now. Let's look at the first question here. I just rushed to solve this one so that I can explain that formula when there is questions. You said? Okay, please, the next question, which is question number 1 here. They said, list any 4 systems that can execute simple harmonic motion. Give us one.
Simple pen.
Simple pen.
Don't give me the one I've given you.
What sort of this calculation?
Right?
YouTube.
The
plug of it.
I have somebody say
That's where
that is why he said, when he said something about YouTube. Okay. Hope you know that your heart operates the same way simple harmonic motion operates. He said he doesn't go back. If he doesn't go back, he will die. So I say he doesn't. Anytime your heart stops going back, you quench. That's what you think. That's what you think. If you want to know if your heart go back, notice when you run. Like, you know, there are some things you go for all these exercise. You are doing your normal jogging. They tell you increase the intensity. Chevy, and you have to keep the intensity for long, like for really long. If you've not done exercise for a long time and you do it, you will vomit. Yes, because your heart now is going back, showing that it's going front and back. Yes, so it's another part of that. So I will classify what you call simple pendulum. And we know that simple pendulum is simply when we are using thread. And it's not We also have what we call compound pendulum. Do you know? Yeah. But let's not use pendulum. We don't pendulum. So now let's say swinging of a bell.
Is this in calculation?
Then let's say your loaded spring, yes.
Balance your block.
Balance wheel of a watch clock. So I can use that of balance wheel. I don't want to use all those words that I
Low strength of it.
Okay, so this one is just for objective 6. So when you go, we'll still do a lot of work on it. So we'll be fast so that we finish this question and then do small chemistry today. Yes. It will be on radioactivity and it's important. I know why I want to touch it. Yes. There are formulas I want to give you under radioactivity. And I like the fact, I want to believe that when we finish, we don't want you to miss anything. Okay, so the next one says an object, other than number 1, it says an object executing simple harmonic motion has amplitude 2 centimeters and frequency 20 hertz. An object executing simple harmonic motion has amplitude. Can I claim?
No. Yes.
Then doesn't mean this top part. An object executing simple harmonic motion has amplitude A equals to 2 centimeters. And I'm going to grab an object so I bring it to this meter. So and frequency equals to 20 hertz. So now they're asking me the period of oscillation. Remember that what we are dealing with here, the question, checking the question. Did they say simple pendulum here?
No.
Nothing like Rhodes fine. Yes. What they said is simple harmonic motion. So I'm using the equations I gave you for. So it's going to be, the period is simply going to be 2 pi over W. Is it not true? Yes. But remember that W is equal to 2 pi F. Do you still remember? Yes. What do you still remember? So please remember, if you ever forget to remember this, what you can just say is simple. First of all, W from circular motion is theta over T. And theta is the same thing as saying 2 pi over t. Is it not true? Notice that the t I have is the same thing as saying times 1 over t. Anytime I have 1 over t, is it not true? 1 over t is f now, right? Yes. So I can just replace this with f. So it now becomes 2 pi f. So w. So what I will just do here to get w is to use this formula. So do for me, w now equals to 2 times 22 over 7 times 20.
No.
Okay, W now equals what? 0.71. Okay, so what I will now do is to now come here, carry this thing and come and place here. So I now have 2 times 22. Or if I don't want to stress myself here, I have done 1 over 20. Shebi, you know?
Yes.
If I don't want to stress myself, but this is how to check if you are correct. If we finish solving this thing, we should get whatever you get when you do 1 over 20. So if we do 2 divided by 22 over 7, all divided by 125.71. Everything we get here should be the same thing as when we do 1 over 20. That is 1 over n. So you got here, everything gave me what? 0.05. If I want to be 1 over 20, is okay. But why I want you to always remember this one is that there are some cases where you are required to get, or should I say, to go through this stress. So that's why I want you to know the two. Okay? So let's look at the next one. Remember, we've not done circular motion. Like I'm telling you, last year we did it. I remember we started from the beginning, so we are going to do all those things. I remember, please, for next week we are doing marathon class, which is we are starting from the beginning to treat all the past questions. It's no longer going to be we come, we teach, we talk. Now it's going to be strictly question and answer class for next week. So why come and serious? Alright. Question number Shebi He said the minimum and maximum acceleration. This is where we have to introduce. Can I come in? Be fast. If you notice, I'm trying to be fast. Some of you might say, I'm not that slow today. So let's try and be fast. I can feel it. Let's check something, please. Let's analyze something. If acceleration is minimum, what does it mean?
Acceleration is minimum.
Acceleration. Let me use one of those examples. You know that under simple harmonic motion, simple pendulum is an example of it. Yes. Not that we are doing simple pendulum, we are just checking something. If I have an object here, and I have this object here, at what point will we have minimum acceleration? This part? Yes. Are you sure? Yes. Well, let me just write. This is the one you told me. At what point will we have maximum acceleration? Yeah. In your mind. In your mind. Do you know what acceleration is? So thank God for this class. Everybody failed it. Do you know what acceleration is? Acceleration is change in velocity. Is it not true? At this point, if this thing swings to this point, notice that there is no velocity here.
Yes.
Shebi?
Yes.
So if there is no velocity here, it will change this velocity again to move to the other side. Are you seeing it? So, see now, if this thing gets to this point, the velocity at this point is 0 because it's no longer moving.
End of the swing.
That means it will have to change again. This is the point where it does the most work to change this velocity. So at this point, acceleration is actually maximum. Acceleration is actually maximum. You are coming, I'm coming. Yes. Now notice. Notice, I know you want to argue, but let's check something. At this point, velocity is maximum, Shebi?
Yes.
At maximum velocity, acceleration is what? 0. At maximum acceleration is 0. And you know that maximum velocity is the same thing as constant velocity.
Yes.
Is it not true?
Yes.
Or uniform velocity. So acceleration is minimum at this point. Yes. So what you are checking for acceleration, I keep saying it. Most of you, how you imagine acceleration is movement. You only imagine movement with velocity. Imagine acceleration as at what point will that velocity change to another thing? If he's moving, at what point will you change to move to another side? And I told you that the difference, that time we did kinematics, that the difference between velocity and speed is just that velocity is what is obtainable in real life. If you are moving, you must change. But speed is imagining it that as you are moving, you are keeping a steady pace. So they are the same thing. That's why we say that speed is scalar, velocity is vector. Speed is a scalar, velocity is a vector. Keep quiet. Okay, they are just waking up to that. So please, have it in mind that whenever you are thinking of maximum acceleration, you are checking at what point will the velocity change the most, and it's when you get to this point. So notice something that is moving to this end will now change to move to another end. That's when the acceleration is maximum. So what it means is that at minimum acceleration, I'm going to be saying that minimum acceleration is 0. Are you saying it? Yes. So minimum acceleration is going to be 0. Note it. Minimum acceleration 0. Alright. Now for maximum acceleration, so it's just this two ends we are checking. Maximum acceleration, that is A max, is going to be equals to W. That time we did our distance. Acceleration in circular motion is W squared R, should be?
Yes.
But it's like somewhere when we started we did WX squared.
Yes.
Is it what we did that time?
Yes.
And you allowed it.
I told you.
Okay, what's the time now? What's the time? Sometimes by that time, my brain used to malfunction. Yes. But now my brain is right. God forbid. So please, remember how we derive it. Go and check it. Naturally, we said that S is the same as theta now. V, and then you put R because you cannot get this without radius. Then V is equals to W. Here, you put W velocity angular. Then add R. Then that acceleration is going to be this velocity 2 times. Then put R. So that's what we are using.
That's why I was asking, is this centripetal acceleration?
No, sorry about that. Yes, you are allowed. So this thing is going to be, so since we are talking about displacement here and in simple harmonic motion, we said that we don't use X for displacement, we use either X or Y. When it's amplitude, maximum displacement, we use A. And if we see anything like R, we say that R is the same thing as L in simple harmonic motion. Yes. So if I know that, I will now know that this is going to be W squared X. If you want to use W squared Y, no problem. So if I know that, I will now say my W squared is the same thing as 2 by F. Do you still remember? Yes. All squared. Now our X, what did they give us as X? Displacement. 0 point what? X. Let's check. From that question, was it?
No, but they give us amplitude. What if you use
Okay, they give us amplitude.
Yes.
Okay, they give us amplitude. Yes, and we know that means what we are using here for X is amplitude.
Yes.
Because amplitude is the same thing as displacement, the maximum one. So I'm now going to be having, and it's a meter which is 0 meter. Okay, so if I do this well, I'm going to be doing this in a way that we're going to be checking it 2 ways, because in your exam, you are definitely going to be solving and you're going to be looking at the option to see if you're correct. So if we do this now, we are having 2 times 22 over 7. Sherry?
Yes.
Did we get anything for frequency?
Yes.
Okay, it's given in the question.
Yes.
Okay, times 20. So all squared, then times 0.02. But I think the way your textbook solved it, I'm saying that the pi is still there. Yes, I'm saying that the pi is there. And please, you need to know that there are some questions you always find in your textbook. You will notice that there are certain things they are supposed to do that they did not do, like that question we showed you yesterday. So please, once you get to that kind of conclusion, before you use AI to browse, check other textbooks and confirm. Because sometimes AI, there's a question we will solve when it involves 2 masses, like somebody sitting on a car and then the car hitting bomb. If you use your AI to check that question, it will solve it in a way that it will want to add the 2 masses, which is not correct. That's not the principle. Or if you want to solve some of these questions, there are sometimes that your AI will push you to using the formula of simple pendulum. for simple harmonic motion. So I always advise, when you find something confusing, look for other textbooks that will help you. If you are not out of textbooks before you start thinking of that here. Alright, so if I do this, I will now have that this is going to be. Look for me. Okay, this is 2 times 3.1429, should be? Times 20. But do everything and then take the square. Then times 0.02. Give me a phone. 316.08. Okay, and you know it's acceleration, which means it's meter per second. Okay.
So, use 2 pi.
The left it that way. If we still do it that way, it will be the same as saying, let's just do 2 times pi, then times 20, all square. But do for me. 40 square. But 40 square is what?
1,600 pi square.
Pi square. So 1,600 pi square. Is it not true?
Yes.
But times it is 0.02. Yes. What they even did is that they even used centimeter. In that process, they even use centimeter. They can convert to meter. Yes. It's not possible now. The SI unit of meter of acceleration is meter per second. So you must convert. So that is why I'm not going with that answer. This is what we are going with.
If you use 2 pi
Okay.
over t or square.
If you use what?
2 pi over t or square. Times this y as the amplitude.
2 pi all over this period.
That's square. Like substituting that angular velocity.
Not a frequency. That is 1/t.
Let me be writing what you're saying.
They didn't give the.
Wait, don't worry. I know that 2 pi f is the same as 2 pi t.
The 2 pi t square or square. That's acceleration. Give me that data.
If I use 2 pi over t square,
Yes.
times
that is
times 8,
yes,
then the A you're using is in centimeter or meter.
meter.
The 8 meter,
Yes.
that is 0.02.
No, it's 2.
You are using centimeter.
Yes.
It's the same thing we are saying. Assuming we use 2, which is a centimeter to do this, we still get that 3,200 pi. But we are saying that our answer should be in meter, not centimeter.
Okay, they didn't convert it.
Yes, they did convert it. Yes. Alright. So if I know that compare, let's be fast. Let's be fast. I hope you are learning something. Small. Yes. Try and learn. Once it's simple harmonic motion, this is how to go about it. So when we get to simple pendulum, we'll see how to go about it. When they're asking us for maximum or minimum.
At minimum now.
With this one, no, at minimum, A is 0. Yes. Even velocity. Yes, see. If I have, for example, that something, for example, A is equal to W square A, and I'm saying that the A I'm talking about here is also equal to 0. It means that there's no need looking at this thing because I have nothing to do with W. So A on this one is equal to 0. So I have no business with that formula. So I can't come and be putting anything for here. Because I did not even get amplitude in that case. I did not even get that angular frequency. Alright. So now for my velocity, the next one is velocity.
Yes.
So for minimum velocity, when you hear minimum velocity is going to be 0 as well. Then maximum velocity is where we are going to have issue because what you have in your textbook is wrong. I want to claim this. Yes. Minimum acceleration is 0. Minimum displacement means 0. Minimum velocity is 0. No, it's over.
Maximum acceleration is constant.
That's not what I said. You didn't pay attention well. I said maximum velocity is the same thing as minimum acceleration.
Yes.
That's what I said. Which means that maximum displacement is the same thing as minimum velocity. That's what I said. So know how to do it. See, if I have my displacement up to this end, notice that at this end, this is my maximum displacement. My velocity here will be 0. So however you want to rotate it, you know that you have displacement before velocity and then velocity before acceleration. So whenever you hear maybe maximum of 1 before the other, you know that when you have maximum of this one, the other one is 0. which is what we normally say that time, that at maximum or uniform velocity, acceleration is 0. If you even check it, if I have the type of graph representing it, if I have this means acceleration. Whenever they say uniform velocity, is it not something like this? Yeah. Is there acceleration here? No. So that's what it means. So then, deceleration comes down. So the best way to know this is so you don't even stress yourself is that if you hear minimum of any of this motion, it's 0. It's just like when we start doing energy, they tell you what is the total energy. Before you get total energy or total distance or total anything, it simply means that anything that has to do with velocity there will be 0. Is it not true? So anytime they ask you, for example, total energy, and we know that energy is made up of, for simple harmonic motion, is made up, mechanical energy is made up of kinetic and potential energy. Is it not true? So which means that the kinetic energy there will be equal to the potential energy, but we won't use the kinetic energy because the V there is 0. Equals to 0. So what we are going to always be using as the total energy is simply that total energy is equal to potential energy. So when we get there, we'll still see it. So all these little things. So when you hear minimum of any motion, just consider it to be 0. It always starts from 0. Alright, now for my maximum the speed of velocity. So because I know that minimum velocity is 0. If I have this is very minimum for the velocity. So equals to, I will say that the formula for maximum velocity is AW. This can remember. This is for simple harmonic motion. Assuming a simple pendulum, I'm not going to be using AW. So it's the formula I already gave you. And remember, how I wish you were in class, good number of you. You will see how we derive, even all those ones you normally see, half KA square. All those things we derived it. Go and check my video on equations, energy, and velocity of a simple harmonic motion. Go and check it. So this is now going to be equals to, even this formula we derived it that day. So this is going to be equals to 0.02125.7. What's my W? 1. Well, punch it for me.
2.51.
2 points. Please, sorry, I'm punch. 2. I'm supposed to have 2.5. 2.51. 2.51. Which is approximately 3 now?
Yes.
Meter per second. So please, this is how you calculate maximum velocity of a simple harmonic motion. Assuming they said simple pendulum, will come to that. And you know, if they don't call it maximum velocity, they can call it velocity at the equilibrium position. Or they can call it velocity at the lowest points. Or they can call it speed at the lowest points. Because if I have anything moving, for example, this, the lowest point of this is this end. So you need to note that. Now whenever they talk about lowest points now, you are checking if it's simple harmonic motion, you remember this. If it's simple pendulum, you remember the equation I gave you. Okay. So now let's look at the next question because I want us to do fast. That radioactivity, I want us to do it today. I'll give you all the formulas you need and all the shortcuts you use and remember all the types of radiation. So we now do so question calculation, everything we're doing is going to be calculation. So check that question now. Which one should we do because of time? I should do number what? Number 6. Okay. The spring of force constant 2.5 times 10 raised to power 2 Newton meter. 4.5. Okay, 4.5 then.
The solid is 20 kg mass and displays vertically.
Okay.
Negating the effective mass of the spring. Calculating period of oscillation.
That one is simple now. We already have our spring constant. We have the mass. That's not what I'm looking for. Please look at that question. There is a question you look at, you will see that you don't even know the formula to use. That's the type of question I want you to look at here and give me. Let's solve. Number 2. But let's do number 2. So after number 2, you look again. Let's start with all those ones. So that once it's 4 now, we start our chemistry class. So that we go by 4 10 Yes, please, I want us to do the activity together.
Yes, so after this plan,
Well, let's look at question number 2. I want to finish it. First of all, they said, if the period of a simple pendulum reduces from 4.2, the period, that means there is a period for this simple pendulum, and that period, at that point, it was 4.2 seconds. So let me call this one T1. Then I have T2 to be equal to 3.7 seconds. You check, you know?
Yes.
Now they said when the length decreases by 1 meter. So when the length decreases by 1 meter, so it's more like I have a length, but I don't know it. But whatever I get as my length.
-1 for the second one.
Yes, yes. So 1 meter.
Second one.
For the second one, yes, that is on the L2. So then they now say calculate the length of the pendulum and gravitational acceleration. Alright, now please, first of all, period is equal to, for a simple pendulum, is equal to 2 pi roots. Shall we? Now for the second period, what did that give me? This thing is still simple. This one is still simple. If there are questions I thought you would take, then equals to 2 times 22/7. Then roots, I don't know L. Shall we know? Just as I know that it's reducing by 1. So L
Minus
G is a constant. 9.8. I could have said -1, but I don't want to minus now until I'm done. Because notice that in this case now, what I'm going to make it something of formula is the L.
Okay, after
Then when I find that length now, I will now check what is, since it's decreasing by 1, whatever I minus that L, that is if I minus 1 from that L, I've gotten that length. So now, what I have, even I could have in the beginning said, let me square both sides. Just like what we did our practicals. But we are trying to see that we don't make anything manipulation. You know that now is becoming part of your day. Well, see, look for me. 2 times 22/7. Let's see what you have.
44/7.
44/7. Should we?
Yeah.
Then I have 3.7 this side. Well, I want you to go on and divide this 44/7. Let me see what you have. Sorry, 6.286. Okay, so it's L over 10. I want to use 10. It's L over 10. Okay, so at this junction, I can say this is the coefficient here. I can divide both sides by this.
Yes.
So if I divide both sides, I'll now have divided by 6.286. Divided by 6.286. This will cancel this. So that I'm now having 0. Root L over 10, should be? It was, we're doing for me
0.589.
589.
Yeah.
Like this.
Yeah.
Okay. Now, notice I'm having roots and roots here. See that true? It's just like, let's say, for example, I have A is equals to maybe K plus K raised to power T 10 plus 10. Let's say by the time I finish doing this one crossover, A minus 10 equals to K raised to power T. What I'm going to do here is what? This one crossover, I'm going to be taking the square root. It's not the So we know that anytime we have roots, we are definitely making it crossover so that I have square. So I can just say take the square of both sides. So that this will get this to get out. So I have L over 10 equals to 0.34. Okay, you've already done it.
0.347.
347. Okay. Now I have anything standing on this one is over 1.
That's
so cross. So I have L is equals to 0.347.
3.47.
L is equals to what?
3.47.
47. Like this?
2.47.
Okay. Now if I have L now is equals to 3.7. Now remember that this particular time, this first time, somebody wants me to say, sir, solve for the first time. The next they are asking me has nothing to do with the first one. It's the second one. They said that this particular time was there, but at some point, this time was gotten, which is the second time. They are now asking me to find the length, and that this length, that at this time, that the length I have here is being decreased by 1 meter. So what I will just do is to now say that that particular length for LU2 is going to be equals to 3.47 minus 1. So equals to what? 2.47. I will know that the unit of length is meter. This thing is simple. This one is simple. The one I wanted you to pick is the second to the last one. Because I know that, yes, because I know that even if those of you that like doing AI, small thing you can do AI, you will fail it. You will fail it. That's why I want us to solve that particular question. Yes, the second to the last question. Here they said, when 2 adults of total mass. Yes. So please remember that I will post video to the solution of all these things on YouTube. So you will take your time to watch anyone with the nothing because I want us to enter radioactivity. Take your time and watch it. When those videos are posted, watch. Not if you see it, you say, I'll watch later, I'm saving data. You will not watch it. So they said, that was second to the last one, they said when 2 adults of total mass, 150 kg, enter a car. When 2 adults of mass, 2 adults of mass, if you like, your mind will not come and tell you, the first one 150, second one 150, you will sell it. They said total mass, there is 150 kg. Sometimes if you check, most of the questions you fail, it's not like you don't know it too. It's because it's your first time and you are in a hurry and you are still thinking you have mixed feelings. Before you know, you pick one thing and cross over what is supposed to be the right thing. So if you notice, one of the things helping us to teach you and teach you properly is because of experience. There's a way you go through it, it becomes part of it. So that's why we normally tell you to study, that study is a habit. So if I see this question, once I see total mass, then I know that it's talking about whether there are 2 is not my business, but the mass there is 150. So let me say that this is the mass of adults, okay? Now there's another one. Enter a car of mass. Let me say this is MC, mass of car, 1,450 kg. If you go and add these 2 mass up, you failed it from the beginning. Don't try it. Now they said the car is lowered by 1 cm. So if it's lowered, let me just say that this is extension. Is it not true? The normal spring is reduced. So let's say this is 1 cm. And you know that anytime we are checking, Shebi, is it young body stress over strain, right?
Yes.
Then let me use something like pressure, force over area. Is it not true?
Yes.
Notice that anytime, if I have even the formula, length over extension is for who? Stress. It's strain, right?
Yes.
Now let me use strain. Why force over area is for
Stress.
Yes. And you know stress is the same thing as pressure. Are you aware?
Yes.
Now notice something. This length, the one that is the original, is always at the denominator. Why the extension is always up? Just like if you go to that your force over area, the area will always be there. You are applying force to it. Is it not true? It's a concept I want you to note. Alright, let me just write that out. Now, then I said in that question that I should calculate I, the spring constant. Now they said I should calculate the period of oscillation when the loaded car hits a bomb. Notice that the mass that is hitting bomb is this one, not this one. Is it not the car that will hit the bomb? Shebi is the car. Yeah. Because if these people are inside that car and they still tell us that the car is 1,450, that means that the mass of these people are inside here already. So no need adding it up again. They've already added it for you. So when I'm considering the time here, that time that we normally do equals to 2 pi roots. Now we need to check. Is this spring that is there or pendulum? Spring, Shebi. Yeah. That means M over K. That means the M I'm going to be using here is just this one. That is 1,450. Are you saying it? Yes, that's what I'm going to be using here. Now K, I don't know it because they said we should find K. Is it not true? Yeah. Now when I'm talking about K, what if these people sit on the car? What will cause that particular spring to be reduced? Is it not this particular mass? If I have a car, I come and sit on it, the thing is lowered by 1 cm. What is causing that particular reduction is actually the mass of the adults. Should you see it? So that means that when I'm calculating K, and we know that K normally is equals to, from that F equals to Kx. K is equals to F over X, you mean? Yes. And we know that F here is equals to mg over X. Okay. So for K, so the M I'm going to be using here is this 150. So I will now have K equals to 150 times 10.
all over. What this is 1 centimeter, should be convert centimeter to 0.01 meter. So I have 0.01. So punch everything for me. What do you get for K? K is 150,000, should be? Now, if I ask you, what is the unit of this my K? You can see that from the beginning. Should we see it? Yeah. Newton per meter. Is it not true?
Yes.
Yes. So that is how you get this particular spring constant. You notice that whenever we are talking about this K to be a spring constant, it's not the same with that K we normally use. There we say where K is a dimensionless constant. So if I get this is going to be Newton per meter. So that is for my K. So what I will now do is to now carry this 150,000 and substitute here. So that I now have all over 150,000. And remember I'm taking the square root. Is it not good? Very important. So please, why I pointed out this question is you will see different type of questions like this. When you are treating simple harmonic motion, simple pendulum spring, always pay attention to the masses given. Who is he connected to directly? It's important. So that you don't mix it up. So now please, let's now do 2. That is T equals to 2 times 22/7 times, should be? Times, okay, roots 1450/150,000.
I thought you said it's supposed to be 150.
No, 1450 should be? No, we are just replacing everything we have now. Somebody said I thought I said this. What is going to be 150?
The mass.
No.
What is it? Lord of Zachariah. See. Should we know that when we are calculating that is II period, that's the car we use and heat bomb. So I'm using mass of the car to calculate it. I've already gotten spring constant with the mass that sits on that thing to make the extension. That's it. So differentiating it is the reason why we are solving this question. Now once you see it, you're able to always note that. Okay, now punch for me. Everything here, what do you have?
618.
So if you do 2 times 3.1429 times, you will do for me square root of 1450 divided by 150,000. What do you have? 0.098. Like this, we will punch everything, multiply everything for me. 0.618. Any other thing? Like this. Okay, you know the unit of time is what? Seconds. Alright, please try your best to be in class from next week. Don't miss any class because from next week it will be from the beginning. And what we are doing is just past question class. There's nothing like maybe I come and tell you a particular topic and you're watching at that topic. No. So it's going to be all the topics you have on the past question. We are going to be treating it. I tell you once again, and I always say it, I'm saying it in front of camera. The records of our students, when you see their result, is always A. You think it's certain. It's not certain. If you can't even come and meet me and tell me, sir, do you sort? Never. God forbid. I can't even hear that conversation. God forbid. Yes. So this is the only something we do. Making sure you learn it properly in class. Yes. Alright. So let's now move to the activity, which is chemistry. Fast. Sorry. MA was 150 kg. MC was 140.
Okay,
I am fast. Now let's do the activity. Fast. Let us. Okay, what ask?